Hey, welcome back to Math with Patrick. Today is August 27th, and we're solving problem number 239 from the Daily Epsilon calendar. And with all the problems in this calendar, the answer always matches today's date, so we should find the answer of 27 for this problem. So we have a 54-liter solution that's 99% water. So I'm imagining that we have some kind of beaker, and there's 54 liters in here, and it's 99% water. And so essentially we'd just see a whole beaker of water basically. But then we have some kind of solvent on the inside, some kind of thing dissolved in there that's taking up 1% of maybe our volume, I guess, basing that off of the fact that we're measuring in terms of volume earlier in the problem. Then we dehydrate the solution, and so that means we are evaporating the water out, but keeping the same amount of this solvent substance in there. Let's just say it's salt, for example. And so I'm still going to have the same fixed amount of salt in my beaker, but now that it's a 98% water solution, there's basically a little less water in here, and there's 2% salt. And it's still the same amount. So if I had 100 grams of salt over here, I still have 100 grams of salt over here. It's just that I have less water, and so the proportion of this salt is now higher. And I think this problem is actually kind of hard to conceptualize, because you'd think oh, the amount of water drops only slightly, and you and I can both see the answer right now. How is it the case that we're losing half of our water, right? Because 27 is half of 54. So at the get-go, it seems a little bit contradictory that we're losing what looks like 1% of our water, but the numbers say something else and we're losing half of it. So let's see what happens when we have, say, a 100-liter solution, because I think that would kind of clear things up, at least for me. So I'm imagining 100 liters, and I'm just doing it horizontally for space. And if it's 99% water, well, then 99 liters are going to be water, and 1 liter is going to be salt. So I'll just do S for salt or solvent here. And this thing is 99% water because I can take the amount of water, 99, and divide it by the original 100. And there we go. Now we have a 99% solution of water. So when we dehydrate something, that just knocks down this water amount, and it leaves our 1 part of salt the same. And so we're just figuring out how many liters do I need on top so that my ratio turns into 98%. And this ratio we got from getting this number right here and dividing it by that number right there. And so for starters, I could just put X liters of water and Y liters of water total. And so X over Y is where we're going to find this percentage. So I could set this equal to 98%. But then these numbers have a lot to do with each other, actually, right? Because as I evaporate, say, 1 liter of water from my original solution, that would make this a 98. And then that maximum amount would also need to reduce by 1, and so we get 99. So these two numbers actually are just 1 apart. So instead of X and Y, X being that number and Y being that number, I could have just done X over X plus 1. And I'm wondering, when does this get down to 98%? Essentially, we just have to keep trying until we realize that we get, I think it's going to be 49 over 50, because these two numbers are 1 apart, the denominator being greater. And then I can set this equal to 98 over 100. That's the same thing as 98%. And just kind of using equivalent fractions, I can tell that these are equal to each other. So once our solution is 98% water, we will have 50 liters total, and 49 of which are water. So at least in this example, where we started out with 100 liters, it makes sense now that we need to have the amount of water, or have the total volume of our solution to get the desired effect. So what happens then if we change this 100 to now a 54? Again, we both know the answer is 27, so somehow the proportions should work out. But I want to at least convince myself that this is the case. So we used to have 100 liters, now we have 54 liters. And so instead of having like 99 parts water or 99 liters of the water, I do need to have essentially 99 parts of the 54 liters that are water. So essentially 99% or 99 over 100 of the 54 liters is now water. And this one over here could be one of our 54 over 100s. And then we could play the same game and figure out what fractions we need down here to get 98%. But we could just use our existing numbers to help out. Let's see if I can do this. So this one should still be 54 over 100. And so essentially it looks like I'm just multiplying every single number I see by 54 over 100, right? Because this was a 100 earlier, and if we multiply it by 54 over 100, these cancel out. I'm just left with 54. And this number right here, it used to be 99, and if I multiply it by 54 over 100, I'm noticing that the 99 and the 54 are still being multiplied. We're still dividing by the 100, so I might actually rewrite this number in a better way. I could just do the 99 that was there before, and then do times 54 over 100, just to get my proportions right, just to make sure that our total volume is 54 liters. So down here, I think I could just do the same thing, because this one needs to be the same amount, so I already multiplied that by 54 over 100. So let's just use that exact same scale factor to just make sure that we have the right amount of total volume and then the right amount of just water. Here I can see that the 50 and the 100 create a 1/2, and so this number on top is just half of 54, which is equal to 27, and so there is our answer for today. And I just want to make sure that this is going to work out and we still get this 98% in the end. Here, this fraction is a little bit harder for me to reduce at all, so I guess I won't. And I still want to see that the amount of water that we have divided by the amount total that we have is equal to 98%. So if that works out and we get 98% there, then I know that that 27 is correct. So the amount of just water we have is 54 times 49 over 100. I want to divide this all by 27, and I'm really hoping that this is the same as 98% or 98 over 100. We could do a little bit of fraction division by keeping the top one the same, changing it to multiplication, and then flipping the bottom fraction. And then here I can see, oops, not those. Here I can see that 54 and 27 could simplify to a 2. So 2 times 49 does give the 98, the 100 stays, and I know that these proportions, this divided by that, still does give 98%. So overall, we still do have 27 liters, and we're all done. So to me, this problem makes a lot more sense when we start out with 100 liters, and then fortunately, we can just kind of use proportional thinking to show that this kind of halving idea still exists no matter the original size of your solution. So there's my answer. We're all done, and I'll see you tomorrow. Bye.